In this video, I want to do a more difficult limit problem. So the problem I'm going to look at is the limit as x goes to 2 of x squared minus 9 over x squared minus 5x plus 6. So as usual, we begin by substituting 2 into the function to see if the function will become undefined. So I notice that if I substitute x equals 2 into the bottom here, let's just do that. 2 squared will give me 4, minus 5 times 2 will give me 10, plus 6. I would in fact get 0. So I know if I substitute x equals 2 into this function directly, the function will become undefined. So what I'm going to do is, I'm going to factorise the top, factorise the bottom, in the hope that something will cancel off and simplify my problem. So let's do that. So we get the limit as x goes to 2. Let's factorise the top. Well, this is just a simple difference of 2 squares. So we have x plus 3 by x minus 3. Factorise the bottom. So it's a regular quadratic equation. So it's x by x, 2, 3, and minus, minus. So now I notice that I can cancel this x minus 3, this x minus 3. So we're simply left with the limit as x goes to 2 of x plus 3 over x minus 2. So now it's just factorised down as far as I can go, and I notice that if I still now substitute 2 into this function, I'm going to have 2 take away 2, which is 0, so it's still going to be undefined. So when you come across a situation like this, the only thing that you can do is go back to basics and take the limit from the left and the limit from the right as x goes to 2. So let's do that. So let's calculate the limit as x goes to 2 from the left of x plus 3 over x minus 2, and we calculate the limit as x goes to 2 from the right of x plus 3 over x minus 2. So let's remember what this is saying to us, the little minus and little plus sign. In this situation here, we're saying take numbers slightly smaller than 2, substitute it into this function here, and see what you get. So if I take a number slightly smaller than 2, let's sub it into the top first. Well, if it's slightly smaller than 2 plus 3, well, up on top we've roughly 5. Not quite, but roughly 5. And on the bottom, we'll have a number slightly smaller than 2, take away 2. So if you think about that, if you have a number smaller than 2, and subtract 2 from it, you will have a negative number. So it will be a positive divided by a negative, give me a negative. And we'll have a number divided by a very, very small number. Because remember, a number smaller than 2, take away 2 will be very, very small. So a number divided by a very small number means it's going to shoot off to minus infinity. So similarly here, we're going to take numbers slightly bigger than 2 this time. So if the number is slightly bigger than 2, again on top you've got roughly 5, a little bit bigger than 5. But on the bottom, if you have a number slightly bigger than 2, and you subtract 2 from it. So a number slightly bigger than 2, subtract 2 will be positive. So you'll have a positive divided by a positive will be positive. And once again, a number slightly bigger than 2, minus 2 from it will be very, very small. So you've got roughly 5 divided by a very, very small number, so it's going to shoot off to plus infinity. So we can say that the limit as x goes to 2 overall of x plus 3 over x minus 2 does not exist. And the reason for that is because the limit from the left does not equal the limit from the right. So, because the limit of this does not exist, we can say that the limit as x goes to 2 of my original problem, x squared minus 9 divided by x squared minus 5x plus 6 does does not exist also.